Alright, engineers, in this video we're going to go over spirometry. So it's going to be a little bit of graphical representation again, but let's try to make the best of it. Alright, so here we have on the y-axis, right? So here on the y-axis we're going to have basically the volume of air that's moving in and out of the lungs, right? So whenever we're just sitting here, like me, just sitting here breathing, okay? I'm just normally just breathing in slowly, quiet inspirations, and I'm breathing out that expiration, right? So just normal breathing in, breathing out. I'm not bringing any extra air. I'm just normally breathing. When I'm just normally breathing and bringing air in and out, that's called tidal volume, right? Now tidal volume on average, if we take an average individual, it's approximately about 500 milliliters. But when I say tidal volume, I'm talking 500 milliliters that are coming in and 500 milliliters that are going out. So let's say I represent here on this actual graph, and again, this is in volume, this is all in milliliters. So this is volume right here on the y-axis. So volume specifically in milliliters. So now here, if you imagine here on the x-axis, it's going to be just occurring over time. So it's basically the amount of volume of air that is moving in and out of the lungs in a certain time period. So just imagine here that we have the x-axis here, and that's going to be time. Now watch what happens whenever the air is moving. So let's say I have here my tidal volume, right? And it's going to come up here, and it's going to move down. And then I'm going to move up here, and it's going to move down. Up, down, up, down. What happens is as this actual air is coming in, then this is my tidal volume inspiration. As it goes down, that's my tidal volume expiration. So now what I'm going to do is I'm just to give it a representation of a different color, watch this. I'm going to come up and I'm going to stop there. At the peak point there, that is my tidal volume inspiration. So right here at the peak, this is my tidal volume inspiration. So from this baseline here up to that top point, that's my tidal volume inspiration. Then what I'm going to do is I'm going to bring this line down from here to here. At that bottom point, the amount of air from that top point of the tidal volume inspiration back down to baseline, that is my tidal volume expiration. Okay, so let's do one more just to make sure it's clear. Again, we go up. That is tidal volume inspiration. So tidal volume inspiration here at the top. And then as I go back down, I move back down and I'm exhaling the air out, just normal quiet breathing. This is my tidal volume expiration. Okay. Now, let's say I'm breathing in normally, right? I'm just breathing in normally, just taking normal breaths in, normal breaths out. What did I say is the average volume? It's about 500. So right here's 2,000, right here's 3,000. Let's say right here in the middle, approximately, is right in the middle 2,500. So let's say this is about 2,500 milliliters, right? If I go from the baseline of this point all the way to that top point, what is that? That's 500 milliliters. This right here is my tidal volume. So what I'm going to do right now is I'm going to kind of put it in a line. I'm going to put like a dash line here to kind of just show here that this point here going up and down, up, down, up, down, up, down. All these points here, this is my tidal volume. Now let's say that I decide I'm going to take my normal inspiration, so just the normal inspiration. So I'm just breathing. And I take in as much air as I possibly can beyond my tidal volume inspiration. So I breathe in normal, I take in the normal 500 milliliters, and then I bring in a forceful inspiration. So now watch what happens here. Let's say I come to this tidal volume expiration, right? I bring in normal air, so tidal volume, inspiration. And then look what happens. I decide I'm going to go ahead and suck in some air, and I start skyrocketing this puppy up all the way up here. So now look, it goes all the way to that point there. And then, eventually, as that air is brought in, we'll come right back down to this point here. So now let's go ahead and put a line right here at the top, and then we're going to bring it back down to the baseline. So again, this right here is my baseline, the peak point for tidal volume. So now look what happens. Bring in normal tidal volume inspiration, right? Just breathing normally. Once I bring in my normal breath, I forcefully inspire. So I'm breathing. That point at which I'm inspiring is going all the way up here. I'm forcing inspiration. I'm forcing a certain amount of volume in. This point here is called my inspiratory reserve volume. So what is this volume up here called? The amount of air that I'm bringing in forcefully beyond the tidal volume inhalation is called inspiratory reserve volume. So inspiratory reserve volume. This is the total amount of air that I'm bringing in beyond tidal volume inspiration. So let's just calculate that. Okay, well, I'm at 3,000. That's when it's really occurring, right? So at this point right here, right at that 3,000, it's going all the way up, and it looks like it's going about, let's say it's about 5,800. About 5,800 milliliters. Okay, so what's the difference between 5,800 milliliters and 3,000? That's 2,800. So this volume here, the amount of air that I'm forcefully inspiring beyond my tidal volume inspiration, this volume here, this point from here all the way up. So look, from this point to this point. That is my inspiratory reserve volume. This is on average about, in an average individual, it's approximately 3,100 milliliters. But in this situation, it's 5,800 minus what? If we go 5,800 minus 3,000, that's 2,800. So in this situation, it is approximately 2,800 milliliters. But understand that in a normal individual, usually male, it's approximately about 3,100 milliliters. Okay. So let's say that we have that forceful inspiratory reserve volume. Okay. Then, as that happens, what happens? We have our normal tidal volume expiration. So we bring in the maximum amount of air that we can, and then after we do that, what do? We exhale, we exhale, we exhale, and then we have our normal tidal volume exhalation. So this is the amount of air that we're forcefully inspiring. Then some of the air is going to go out just normally, and then after we hit that point of the maximum amount of air that we brought beyond tidal volume inhalation, then we're going to have this little tidal volume expiration. So let's go down with our tidal volume expiration. So this is our tidal volume expiration. Then let's say that we do it again. Let's say that we come back over here and we have another tidal volume inspiration. And let's say that I bring another tidal volume expiration. But then I'm like, you know what? I want to forcefully exhale. Let's say I'm trying to be able to do abs, right? Or whatever it might be. And I try to breathe out as much as I possibly can. So for example, let's say I'm breathing. I'm exhaling as hard as I possibly can. I'm forcing as much air as I possibly can out from this normal tidal volume expiration. So look here. I'm going to bring this down to about right here. Let's say I come to about right here and I go back up. So if I come to this point right here, let's do this distance here. I'm taking from my normal tidal volume expiration and I breathe out as much as I possibly can beyond that tidal volume expiration. Look, I come from this distance here to this distance here. I'm going to try to match this up here. If I match it up, it's right around about 1,200. Okay? So that's about 1,200 milliliters. What is this called? What is this total volume of air that I'm expiring as hard as I possibly can beyond my tidal volume expiration? This is called my expiratory reserve volume. Okay? And this works out perfectly because on average, the expiratory reserve volume is, in a male, usually approximately 1,200 milliliters. Okay? Now, we have our inspiratory reserve volume. We have our expiratory reserve volume. And we said, what is our normal tidal volume? Our normal tidal volume is going to be approximately, what did we say? We said it was from 25 to 3,000. So let's write that one down. And again, we have to be very, very particular. The tidal volume is the amount of air that's going in and out. So the tidal volume inspiration is 500 mils, but that same amount of air is coming out, that is going to be 500 mils. So technically, tidal volume as a whole is approximately 500 milliliters in this scenario, and it's 500 milliliters on average in a male. Now, we have our tidal volume, inspiratory reserve volume, expiratory reserve volume. There's always a certain amount of air. So whenever I forcefully exhale as hard as I possibly can, when I did, okay, ready? There's always a certain amount of air remaining in my lungs. So no matter how hard I try to breathe, there has to be a certain amount of air that remains inside of my lungs. Why? Because if I could breathe it all out, my lungs would collapse. So I don't want my lungs to collapse. So I always have to have a certain volume of air that's remaining in the lungs to keep my alveoli open. So let's say we come to this point here, right there. From this point here to this point here. So from this point here to this point here, this is called my residual volume, my RV, okay? So let's fix this up again. It's going to be my residual volume. And why do you need to have residual volume? Because the residual volume is the volume of air that remains in the lungs to keep the actual alveoli open. If we didn't have that, our actual lungs would collapse, right? So our normal ERV, which is this forcefully expiratory volume, is 1,200 mils. And then you can imagine here, if I come here, this is about 1,200, all the way to about 0, what would you expect my residual volume to be? Approximately 1,200. And in an actual average adult male, this is the same thing, approximately 1,200 mils. So now, quick recap of these, and then we're going to do some capacities. Tidal volume, what is it again? By definition, it's the volume of air that's coming in and out of the lungs during normal, quiet breathing. I'm not doing any forceful events, right? That's approximately 500 milliliters. What is this one? Inspiratory reserve volume. It's approximately 3,100 mils average in males, right? In this case, it was 2,800. How do we define that? It's the total volume of air that's coming that we're taking and inspiring forcefully beyond what? Beyond the tidal volume inhalation. So think about it like this. I'm breathing normal, and I bring in as much air beyond that tidal volume inspiration. Okay? Then, what is this one? Expiratory reserve volume. My expiratory reserve volume is the amount of air that I'm forcefully exhaling beyond my tidal volume expiration. So in other words, I'm breathing normally. I breathe out as much as I possibly can. As much as I possibly can. That amount that I breathe out beyond tidal volume exhalation is called my expiratory reserve volume. That's on average about 1,200. But if you noticed, I couldn't just keep breathing and breathing and breathing. There has to be a certain volume of air in my lungs that has to stay there to keep my actual alveoli and my lungs open and patent. And that's called residual volume. Now that we know that, we can calculate certain capacities to kind of give us like an idea of lung function. Okay, so again, we got all that. Tidal volume is normally 500 mils because you go from the distance here, 2,500 to 3,000. Good. And it's the amount of air going in and out. Inspiratory reserve volume, you go from this baseline point here all the way up here, move it over. And again, you go from this point we said was about 5,800 minus 3,000 gives us about 2,800. But on average, it's about 3,100. Then we say we go from this baseline here, which is about 2,500, and we go here to about, we said 1,200. Now, 2,500 minus 1,200, this should actually be 1,300. Okay, this should be 1,300. But on average, it's normally 1,200 milliliters. Okay, that's the average. Okay? And then the last thing we said was if we go here, from this point here, we follow it over to about 1,200, and then we go from 1,200 down to 0, that's the residual volume. Now what we're going to do is we're going to go ahead and determine capacities, determine pulmonary function. Okay, so we have a couple different capacities that we have to calculate here. We're going to go over inspiratory capacity, which I'm going to denote as IC. We're going to go over expiratory capacity, which I'm going to denote as EC. We're going to go over functional residual capacity, which is FRC. We're going to go over vital capacity, which is VC. And we're going to go over TLC, which is total lung capacity. Okay, so these aren't that bad. Okay, we're gonna really try to make sense of them. Inspiratory capacity is defined as the total volume of air that you can bring in, total. So think about it. I'm bringing in air with my tidal volume inspiration, and I'm bringing in air with my inspiratory reserve volume. That's it. That's all it is. I'm just taking my tidal volume, which is this point to this point, so 500 milliliters, plus my inspiratory reserve volume, which was 2,800 milliliters. So all it is just tidal volume plus IRV. Well, if it's just tidal volume plus my IRV, and if you really want to be particular, you could say tidal volume inspiration, if you really want to be particular, plus my IRV, this we said was again about, what did we say? This was tidal volume was 500 mLs, plus the IRV, which was about 2,800 mLs. And if you do the math for this bad boy, which I'm not always great at, so I got to do it here. For this part here, 0, 0, 3, 1, 3,300 mLs. So in this situation, this person has an inspiratory capacity of 3,300 milliliters. So 3,300 milliliters. That's their inspiratory capacity. Not too bad. If we do expiratory capacity, it's the same thing. It's the amount of air that I can breathe out. Okay, so I'm exhaling, my tidal volume exhalation is this point here, and then I'm forcefully exhaling from that tidal volume expiration all the way down to this point to where I can't exhale anymore. That is their ERV and tidal volume expiration. So if that's the case, then all I'm doing is I'm taking my tidal volume expiration and I'm adding that to my ERV. If I'm being very particular, it's the tidal volume expiration. Well, we said tidal volume is approximately 500 mils because there's 500 mils going in and 500 mils going out. In this situation, the ERV here was about 1,300. So now we got to add that in. So 1,300 mLs. And that's going to give us about 1,800 mLs. I can actually do that math. All right. Now, we go to functional residual capacity. Functional residual capacity. Now, think about this. When I'm just normally breathing, I'm not forcefully expiring all the time. I don't want to look like a goof all the time when I'm, but that's the whole concept is you're not doing that the whole time. So if you think about just the normal amount of air that's in your lungs without even forcefully expiring, that's technically this ERV and this RV, because I'm not always forcefully exhaling. So technically the amount of air that's in my lungs during just normal breathing, just normal inspirations, normal expirations, is my expiratory reserve volume, which is always there. Like think about it, I don't even have to do anything, and I can just, that's already there. But remember I told you I have to have a certain volume of air remaining in my lungs so that they don't collapse. So my functional residual capacity is the ERV plus the RV. Okay, so this is my ERV plus my RV. And again, ERV is 1,300 plus 1,200. So it's going to be 1,300 mils plus 1,200 mLs. And this is going to equal approximately about 2,500 mLs. Okay, cool. And again, these are just going off of this graph. Obviously, the true average values will be dependent upon the standardized numbers that you would get from a male or female. But all of ours can differ a little bit. Okay, vital capacity. Vital capacity is going to be defined as the total volume of air that I can bring in forcefully and the total volume of air that I can exhale forcefully. Okay, well, let's think about this. I always have to account for my tidal volume, no matter what here. So I'm going to have my tidal volume here in this situation because air's coming in. But then I have to account for the air that I'm forcefully bringing in. So I have to account for the air coming in during normal inspiration. Then I have to account for the normal amount of air that I'm inhaling beyond that tidal volume inspiration. Then I have to account for the amount of air that's actually being forcefully expired. So I have to add my ERV plus my tidal volume plus my IRV. So from this point to this point here, this whole point from the IRV all the way down to the ERV, that is my vital capacity. Because it's the amount of air that I can bring in normally, during normal inspirations, plus the amount of air that I can forcefully inspire, and the amount of air that I can actually, forcefully expire, right? So amount of air normally inspired, forcefully inspired, and forcefully expired. That is my vital capacity. So in other words, what is the whole calculation here? I'm going to have to do tidal volume. And again, some people will be like, well, don't you have to add the tidal volume inspiration, expiration? No, because it's going to be the same amount of air going in, going out. So we don't have to do that. We just say it's one whole tidal volume here, and we just say tidal volume plus ERV plus IRV. So tidal volume is about 500 mLs. So we're going to do this one under. So 500 mLs, right? Plus ERV, which in this situation was 1,300 mLs, plus 2,800 mLs. Oh boy, I got to do all this math here. Okay, so 2,800 plus 1,300 plus 500. So 0, 0, 8 plus 3 is 1, 1 plus 5 is 6, sorry guys. And then 2 plus 1 is 3, so this is 4,600 mLs. All right, so 4,600 milliliters is the total volume that I can bring in normally, plus the amount of air that I can forcefully inspire, plus the amount of air that I can actually forcefully expire. That's my whole vital capacity. Last but not least is the total lung capacity. Total lung capacity is the total volume of air that can be occupied in your lungs. So accounting for the residual volume, the amount of air that's always there, the amount of air that I can forcefully expire, the amount of air that's normally coming in and out, and the amount of air that I can actually forcefully inspire. So if that's the case, then I have to add all these puppies. Well, I'm not going to do that because I'm just going to think here simply. I'm going to go from 0 all the way up to this top point here, which I said was 5,800. But I can already cheat now. I don't have to do all that math and look like a goof. So it goes like this, right? Tidal volume plus ERV plus IRV plus the residual volume. Because I told you, it's the total volume of air that your lungs can occupy. So from the IRV all the way down to the residual volume. So it goes from 0 to the top of the IRV, which we said was about 5,800. So I'm going to cheat a little bit, and I'm going to do 5,800 mLs. Which I probably could have made it myself easier and done a lot of them. But all right, it's too late for that. So we got our capacities now. So now we understand how we get the capacities. We understand what these volumes, how you can gain these from the graph, and we understand what they mean. Now that we understand that, we have a good concept of what this actual pulmonary function can lead to. But you know, this isn't the greatest at determining pulmonary function. There's another test that we can use to determine pulmonary function. It's a lot better. And that's what we're going to talk about in the next video. I'm just going to mention it for right now. It's called forced spirometry. And in this situation, we're going to go ahead and monitor the person's pulmonary function by them, taking an apparatus, breathing as hard as they possibly can into that apparatus. So taking as much air as they can in, as much air as they can blowing out. And we're going to monitor that at 1 second and until they stop actually expiring. And that's going to help us to determine if this person has normal pulmonary function, if they have an obstructive pulmonary disorder, or if they have a restrictive pulmonary disorder. All right, engineers, I hope you guys enjoyed this video. I know it was a lot of math. I know it was a lot of graph and stuff like that. I hope it made sense. I hope you guys did enjoy it. If you guys did, please hit the like button, comment down in the comment section, and please subscribe. All right, engineers, until next time.